Have you ever wondered how springs work? Those seemingly simple coils of metal tucked away in a multitude of devices, performing a myriad of tasks. Today, we delve into the science behind the humble spring, its workings and varied applications. Springs, at their core, are devices crafted from elastic materials, capable of returning to their original form after being stretched or compressed. The most common material used is metal, specifically spring steel, but non-metallic materials like wood can also be used. The magic of springs lies in their ability to store energy. When you compress a spring, you're doing work to it, and that work gets stored as potential energy, ready to be released when the spring is allowed to return to its natural state. The functionality of springs is governed by a principle known as Hooke's law. Named after the 17th century British scientist Robert Hooke, this law states that the force a spring exerts is directly proportional to its extension. In simpler terms, the more you stretch a spring, the harder it tries to spring back, and the force it uses to do this is measured by something we call the spring constant. Coil springs, the ones we're most familiar with, are just one type of spring. Springs can take many forms and are classified based on how the load force is applied and their shape. There are compression springs, tension springs, torsion springs, and many more, each with their unique characteristics and applications. Speaking of applications, springs are everywhere. They're in the pens we write with, the cars we drive, the watches we wear, and even the mattresses we sleep on. They're used in simple tools like tweezers and complex mechanisms like clocks. They're integral to the functioning of many mechanical devices, and without them, our world would function quite differently. In physics, springs play a crucial role in the study of simple harmonic motion, where the energy of a spring mass system remains constant. The potential energy is proportional to the displacement, and the kinetic energy is proportional to the velocity. The period and frequency of oscillation in a spring mass system can be calculated based on the spring constant and the mass of the object. To summarize, springs are incredibly versatile devices that store and release energy. They function based on Hooke's law and can take many forms, each with its unique properties and uses. They're an integral part of many everyday objects and play a crucial role in the world of physics, particularly in the study of simple harmonic motion. So the next time you use a pen, drive a car, or even lie down on a mattress, remember the humble spring working tirelessly behind the scenes to make our lives just a little bit easier.